of an Almont-based company called Potential Difference, Inc. And our company is an R&D company. Our business model is intellectual property development and licensing of our intellectual property. Our technology focus deals with, initially it dealt with reducing generator armature reaction. And for anybody who doesn't know what generator armature reaction is, I need a volunteer. Who wants to volunteer? You can volunteer.
Sure.
Okay.
Sure.
So come up here. This is an electric generator. Okay. This is the load. Okay. Now, I want you to turn the electric generator. Okay. You can see how easy it is to turn. Okay. Right now the generator is on no load. It's very easy to turn. So when I place it on load,
A lot harder.
okay. What you've just shown everybody is generator armature reaction. Okay. When Ontario Hydro's generators are delivering power to the grid, the more light bulbs that are lit, or the more power that they need to put into the grid, the harder it is for them to turn their generators. So they have to put in more mechanical power, more hydroelectric, more nuclear, more coal, more gas, whatever it is to keep these generators turning. And again, the more light bulbs that are on there, the more generator armature reaction is produced. Okay? The generator armature reaction that is produced inside this generator is simply a magnetic field that is created inside the generator. So you have a magnetic field that's generating the electricity, and then you have another magnetic field that's being produced inside the generator, which makes it harder to turn. Okay? So what our research focused on initially was looking for ways to reduce generator armature reaction, to make the conversion of mechanical energy to electrical energy more efficient. What we discovered and what we are now licensing on a global level is several innovations that not only eliminate generator armature reaction, but actually reverse it. And what that means is when you would be turning this, when it's connected to the light bulb, it would actually be easier to turn than when it was on no load. So that's what I'm going to be showing with the first prototype. And we have two prototypes that do pretty much the same thing. I'm going to show basically just the simplest version first. And this is a prototype that reverses the armature reaction. If we were talking about electric vehicles, generator armature reaction is what's referred to in electric vehicles as regenerative braking. And what you experienced here is the braking component of regenerative braking. So our innovation represents a new paradigm for electric vehicles, where electric vehicles can operate in regenerative acceleration mode. And that's what I'm going to be basically showing you with one of our display prototypes, is our ability to allow an electric vehicle to recharge its batteries and accelerate the vehicle at the same time, rather than decelerating the vehicle. So I will fire up the first prototype here. Luke, if you want to just slide over there so you can. So I'm just going to do the demonstration, and I'm going to show you conventional generator operation. So what that means is the prototype is set up with a conventional generator coil so that it operates exactly like the conventional generator over there, in that when the load comes on, the generator will slow down and it's increasingly harder to generate power, and you have to put more energy back into the system to maintain the power to the load. And then I'm going to show regenerative acceleration, where I incorporate our innovation into the system, and it'll be pretty obvious. The generator will accelerate under load, and I'll go through it more than once if people need that.
Hugmynd snýst það að fá rafalið til að framleiða sama magna rafalið við miklu minni tork sem ekki við, þannig að við getum framleitt með þessum rafalið sama rafalið fljótt
So what I'm going to do is I'm going to bring our generator up to operating speed at about 3,000 RPM. And then I'm just going to lower the input and get a steady state speed of around 3,000 RPM. And then I'll put the conventional generator on load, and we'll see what happens. And then I'll put the regenerative acceleration generator on load, and you'll be able to get an idea of the difference in performance. Okay, so we're operating on no load right now. Steady state speed about 3,340 RPM. I put a load on the conventional generator. The conventional generator creates a counter torque, decelerates the system, and causes the motor to deliver more power to the generator in an attempt to prevent the deceleration. And now I'll put it in regenerative acceleration mode. Now we're operating with our innovation. Output to the load is increasing, the speed of the system is increasing, the power required by the drive motor is decreasing. Welcome back to the potential difference regenerative acceleration demonstration, part 2. We're back in the lab now, and I just want to reiterate what we saw in the corporate boardroom demo. And what we saw was a conventional generator. When it is operating on no load, it is very easy to turn. The only thing that is preventing the turning of the generator rotor is the bearing friction, the inertia of the rotor, and a small amount of cogging torque that would be in this permanent magnet generator. Now, when the generator is placed on to a load, as I'm doing with this switch, the load current creates a magnetic field inside the generator that creates a counter electromagnetic torque, which is produced in the opposite direction that I'm trying to turn the generator. So now I'm trying to turn the generator in the clockwise direction, and as you can see, it takes a very large amount of energy just to get that light bulb to flicker. The current that's flowing in the light bulb is creating a magnetic field inside the generator that is creating a torque that's working in the counterclockwise direction. This is why it's harder to turn when the generator is placed on load. The magnetic field that is produced is called armature reaction. In electric vehicles, it's called regenerative braking. And the innovations, the regenerative acceleration innovations developed by Potential Difference Inc. has the capacity to reverse the polarity of the magnetic field that's produced in the generator. So when the regenerative acceleration generator is placed on load, the generator produces a complementary torque to that initially supplied by whatever is turning the generator initially. So what we're going to see again in this demonstration is we're going to see basically an opened up version of that generator, and we have generator coils here. We have our permanent magnet rotor, which is hidden obviously inside this closed generator. And when we place our conventional generator on load with this switch here, we will notice that our generator creates a counter electromagnetic torque which decelerates the system. And again, this would be observed in an electric vehicle as regenerative braking. And when we place the regenerative acceleration innovation online, we will see a reversal of the regenerative braking paradigm, and we will see regenerative acceleration. So I'm going to be right back, and I'll start up the generator, and we will be able to show you the difference between regenerative braking and regenerative acceleration. We'll be right back. Welcome back. We are now operating with our regenerative acceleration generator, operating at about 3,050 RPM, and we are on no load right now. This is the voltage across our load, and this is the current through the load, and as you can see, we are on no load. So now I'm going to reduce the input a little so that we are starting with a no load scenario where the speed is actually dropping. Okay. So now the RPM of our system is decelerating, and I'm going to put the conventional generator on load, and we'll see what happens. So we're producing about 0.8 amps through our load, 10.2 volts, and the system speed is dropping rapidly. Now I'm going to put it in regenerative acceleration mode. Okay, so I've just placed the generator in regenerative acceleration mode. The voltage to our load is increasing. The current to our load is increasing. The input to our drive motor is decreasing, and the speed is increasing. This means that the regenerative acceleration generator coil that's in the demonstration prototype is creating a complementary torque to that which is supplied by the drive motor. And this causes the generator to accelerate under load. So now we'll put it into conventional generator operation again, so you can observe conventional generator armature reaction. Okay, so now we're operating in conventional generator mode, just like this generator. Our conventional generator coil is sending power to the load, and the load current of 0.83 amps and dropping is creating a counter electromagnetic torque inside the generator, which is decelerating the system, and the drive motor is working very hard to prevent the deceleration. So now I'll put it in regenerative acceleration mode again. Now we have halted the deceleration, and in fact now the system is accelerating once again. The input power to the drive motor is decreasing. The output to the load is increasing. The voltage across the load and the current are both increasing, and the system is accelerating, and we are now operating in regenerative acceleration mode, and we are reversing the polarity of the magnetic field that is produced inside a generator, and we are creating complementary electromagnetic torque while our generator is under load, or regenerative acceleration, or you could say an accelerative armature reaction. So I will be right back, and we'll be showing you the same operation in a motorized version of this generator prototype. We will be right back. Welcome back to part 3 of the regenerative acceleration generator video, part 3. Right now what we have is our dual rotor regenerative acceleration motor generator operating with 2 motor coils. There's 3 coils in this dual rotor prototype. 2 of the coils are operating as motor coils, and they are rotating the system at 167 RPM. We are putting in 50 volts of DC at 0.47 amps, and this prototype is unique in that we are collecting the discharging motor magnetic field and sending it back to our batteries. And right now our battery voltage is 12.81 volts. We are putting in 0.49 amps of current into the 2 motor coils, and we are collecting 0.86 amps and sending that back to our batteries. So what I'm going to do with this prototype, as per the other demonstrations, is I'm going to show the prototype operating in regenerative braking mode, and then I'm going to show it I'm going to show the single coil, that's the single ReGenX coil that's in the prototype, operating in regenerative acceleration mode. And so we'll start, we'll bring the system up to 500 RPM, and then we'll show conventional generator operation. And since this is an electric vehicle retrofit prototype, I'm going to be using this universal motor in concert with the ReGenX motor. And so I'm just going to plug that in now. So the regenerative acceleration generator can be operated as a motor in concert with the electric vehicle motor, and once up to speed, the regenerative acceleration ReGenX motor can operate either as a regenerative braking generator, or as we're going to see, a regenerative acceleration generator. And when it's placed in regenerative braking mode, obviously the generator coil will send power back to the batteries, but it will decelerate the system as per any electric vehicle regenerative braking generator. And when it's in regenerative acceleration mode, it will send power back to the batteries, but it will not decelerate the motor. In fact, it will accelerate the motor, or accelerate the electric vehicle while it's recharging the batteries. Okay, first step is to bring it up to 500 RPM. We'll take it up to 500 RPM, and then we'll show you conventional electric vehicle regenerative braking. Okay, right there. Sending 0.19 amps back to our battery, and our battery is charging. This is simply due to the discharging motor flux in the motor, the ReGenX motor. So I'm going to put it into conventional generator mode, as we saw with this generator. So now we are in regenerative braking mode. The generator is decelerating the system, and we are charging our battery. So we'll take it off. Now we're in pure motor mode. And I'm going to bring it up to 1200 RPM and then put it into regenerative acceleration mode. There. We're at 790 RPM. Our battery is charging. We're putting 3 amps back into our battery. And now I'm going to put the prototype into regenerative acceleration mode. acceleration mode. And the system is accelerating. Battery is charging. And I'll take it off. Put it back into regenerative acceleration mode once again. Putting 3 amps into our battery from our motor flux selection and 0.6 amps from our regenerative acceleration coil. And our system is accelerating. So I'll take it off load and we'll just watch the RPM. So now we're in no load. No load on the generator. Now we'll put it on load. Regenerative acceleration mode. Battery is charging. 0.6 amps to the battery.